We do have our homeworks due tonight, so I hope you've had a chance to check them out. And I hope that everybody knows we're having our test on Friday. So the test on Friday, I don't think we need to do a big review for it because it's actually mostly the same stuff from the first test. But I will just say the test on Friday covers all of the topics number 1 through 12. And the new ones, so you're going to see all of the old questions again. You should only do the ones that you don't already have full credit on. The new ones are number 11, which is the bonds-off, and number 12, which is the determine possible outcomes. And both of these are on the homework for this week, so I would suggest, if you want some practice, certainly do the homework first. The bonds-off and the determine possible outcomes. So when you take the test, everybody should be doing these 2 questions, and then you should also do all the ones that you don't already have full credit from the first test. So I hope that you have looked at your grades from the first test. You will need to know which ones you have credit on, and you should. If you want to, I suggest bring your big checklist, just so that you will be able to remember, which ones to do, or you can remember if you like. And please don't write a bunch of other stuff on your checklist, because I don't want you to be writing your notes on there. Just bring a nice, clean checklist with some check marks on it, and it'll be great. I think I don't have much else to say. I didn't prepare a bunch of review stuff like I did last time, just because there's only really 2 new things on there. And they are both things that are on the homework for today. So I hope that everybody feels at least, you may not be totally ready at this point, which is fine, but at least you know what's up with that. Anybody have any questions? I'd be happy to talk about anything if anybody would like to. Yeah? Number 6 on the homework for today? Yeah, so that's this one, determine the possible outcomes. Yeah, we can talk about one like that. Actually, what I was planning on doing today includes some of that. So maybe we will end up doing at least one of these today. And then maybe at that point you can ask questions, and if we like, we can talk some more about it. Yeah, great. All right, one other little announcement, I don't know if you care, concerning the test on Friday. I will not be here. Unfortunately, my kid has an important medical appointment, which I was not able to schedule at any other time. So one of my dear friends and colleagues will be here to look intimidating and give you all the tests. I hope that you don't mind. They will be very kind, and they can sit here, give you a test just as well as I can. All right, and I will instruct them to answer any questions that you might have about the test in the way that I usually do, which is to say, if there's something wrong with the question, they can help you out. If your question is more like, I'm just not sure how to do this one, I will say, I'm not telling. Right. All right, great. Please let me know if you want to talk about any of the old ones one-on-one with me. I would be happy to do that. One last announcement before we get going, and that is I found some AirPods in this classroom last time, on Friday. It was much later in the day, so I don't think it was any of yours. But if you think it might be yours, let me know. I got them in my pocket right now, actually. I don't think they're yours, but I emailed my whole class, the people I thought it was theirs, but none of them is interested. Maybe they just got new ones. In that case, they're mine. No, I will keep them safe for you. All right, great. Let's talk some more about the gerrymandering then. So I would like to actually talk about this example again. I hope that some of you at least have this from last time. I have some more if anybody doesn't. This was a handout that I handed out last time. Actually, sorry, I didn't want to do that first, but please do get this paper out. Like I said, I brought some more if anybody doesn't have it from last time, but I want to try one last one before we get started. This is a little review, and this is what she was asking about, this determining possible outcomes thing. I just wanted to do one more example before we get going. Here's a question that is very much like the ones on the homework, just with different numbers. So let's say we have 15, I'm going to say the dark and the light voters, 15 dark squares and 9 light squares. All right. For a problem like this, you don't even need to look at the picture according to what I'm asking you here. And so that would be, I suppose, 24 total voters. And we want 4 districts. Did I say 24? Sorry, my numbers are messed up on this paper. I don't know what I was thinking. All right, that's fine. We want 4 districts of 6 voters each, right? That would make a total of 24 voters. I wrote 4 districts of 7 voters each on my paper, which doesn't make any sense. That's all right. Okay, and the question is, what are the possible outcomes in terms of who can win how many districts? Determine the possible outcomes of the D versus L districts. All right? This is exactly like 2 of the questions on the homework are just like this with different numbers. All right? So the way that I would think of this, first of all, there are 4 districts, and so the possible outcomes that could happen. Now I'm going to whittle these down a little bit, but the possibilities, just because there are 4 districts, this is sort of like without thinking about much of anything. Just because there are 4 districts, it could be the D's win all 4 and the L's win 0, or maybe the D's only win 3 and the L's win 1. So these are all the possibilities. It could be 4 D's, 0 L's. It could be 3 D's, 1 L, 2 D's, 2 L, 1 D, 0, 3 L's, or 0 D's and 4 L's, right? Now, actually, many of these are not possible, but just before getting into the math, really, these are like all of the even theoretically possible ways that this could go. Yeah?
How do you come up with them before solving it and figuring out which are the actual possibilities?
Which of these are actually possible, you mean?
No, like how do you know to write? Are you just like...
It's because there's 4 districts total.
Yeah.
And so, how could you divide up these 4 districts? Like, what could possibly happen in terms of who wins? Well, the D's could win all of them, or the D's could win only 3 of them, or they could win only 2 of them. So I'm not even doing any like fancy business here. This is just like, it's like if I have 4 apples and I want to give them to 2 people,
Okay,
well, I could give all 4 this way, or 3 and 1, or 2 and 2, or 1 and 3, or 0 and 4. All right. So this little list here you can come up with without even thinking about the numbers at all. Now, we do have to consider which are actually possible. So these are like the sort of theoretical possibilities, right? Without even thinking about which ones of these are actually realistic in terms of how the numbers could work out. And how do we figure which ones are actually possible? Up top, you see there are 15 D voters and 9 L voters, 4 districts of 6 voters each. We should think about the threshold. This is the most important thing to think about in these problems. The threshold to win each district the threshold to win in each district. There are 6 voters in each district. Can someone say how many do you need to win out of 6? Yeah? 4. Yeah, you need 4 voters to win each district. If you had 3 out of 6 is a tie, and I don't want to talk about ties, so if you want to win, the threshold to win each district is 4 voters, all right? And so, let's think about the D's. The D's have 15 total voters. So, and this is the part when I'm actually going to do some thinking about this. They can win up to districts. This is the important step. Anybody want to fill in the blank? Sorry, that says districts. I'm trying to squeeze it in on the edge. I'll write it better. You need 4 to win each district. These folks have 15. How many could they possibly win? Could they win all 4?
3.
Only 3 of them? You don't seem sure. I think the question, could they win all 4 of them? I say no, they can't, because they need 4 voters to win each one. So winning all 4 would require 4 times 4, which is 16, but they only have 15 of them, all right? It's not enough. They don't have enough voters to win all 4 of them. Could they win 3 out of 4? I think that is possible, because 3 districts would require 3 times 4, which is 12, and they do have 12. So I'm going to say they can win up to 3 districts, all right? And if you want to explain why is that? It's because since 3 districts needs 3 times 4 voters, I'm multiplying by the thresholds here, which is 12, and they have 15. So they can actually win 3 districts. All right? But could they win 4 districts? No, because 4 districts would be 4 times 4 voters, which is 16, and they don't have 16. They have only 15. All right? So they can win up to 3 districts. Having said this, it means we can actually eliminate one of those theoretical possibilities over there. I think 4D 0L is not possible. That's because we just said they can win up to 3, but the D's cannot win all 4. And so, because of that, because of this reasoning, I'm going to cross out that one. 4 D's is not possible, because that would require 16 votes, and they only have 15. All right? But from the point of view of the D's, the other ones, they are possible. All right? You could win 3 for the D's. Okay? And then, so this is kind of, we're sort of halfway done with the reasoning here. We should also consider the L's. How many could the L's win? Like, for instance, I have written this possibility, 0 D's, 4 L's, but is it really possible for the L's to win all 4? I think it's not, for similar reasons. So I'm going to try and write similar words here about the L's. L's have 9 total votes. I'm trying to copy this paragraph here, but just about the L's instead. It's different numbers, but the exact same reasons. L's have 9 total votes, so they can win up to a certain amount of districts. You got to think, it takes 4 to win each individual district. They have 9 total, so how many can they win? Show me the fingers. I see several fingers like this. 2. They can win up to 2. That would require 2 times 4, which is 8, and they have 9, so they can handle that. They cannot win 3, though, because winning 3 requires 12 total votes, and they don't have 12. They have only 9. All right, so they can win up to 2 districts. All right, the L's can never win more than 2.
So why can they win up to 2 districts? Like, what's the reason?
It's because this is so it's similar to this parenthetical that I wrote up there. Since 2 districts requires 2 times 4, which is 8,
Okay.
and they have 9.
Okay.
And so they do have enough, all right? But 3 districts requires 3 times 4, which is 12, and they don't have enough for that because
Okay.
they only have 9.
So like you kind of make it up as you go. like you figure out like what you're multiplying, and then like you're like you see if that can go into the number.
Right. You basically, you have this threshold in mind, which in this example is 4. And then I think about how many multiples of 4 can I get with 9? I could get 4 times 1. I could also get 4 times 2, which is 8, but I can't get any more than that.
Oh, okay.
Yeah.
Okay.
So because of this, the L's can win up to 2 districts. That means I can cross off some other of these theoretical possibilities. The L's can win up to 2. The last one is not possible then. They can't win 4. And also this one is not possible. The L's cannot win 3. So these 2 have been X'd out because of that, right? And so, in conclusion, my final answer is those other 2 that I haven't crossed out yet. Those are the actual possibilities that can really happen in this example. So the possible outcomes are, what did I say, 3 D's, 1 L's, and 2 and 2. The others are not possible. Right.
I have a question.
Yes.
On like the test, are you gonna provide like you know how you gave us that sheet with like the darks and light?
The
boxes?
pictures?
Yes. Could you provide that on the test in case some of us want to use that as a way to also, I don't know, check our work and stuff?
I would say I might and I might not. I think looking at the picture to solve this problem is not helpful.
I think why use it to like go back and check to make sure that my possible outcomes are possible.
Yeah. Like by actually drawing.
Yeah.
Right. I think you could always just make up your own picture if you want to do that. I would say, to me, the picture is a distraction here. I mean, I suppose it is. You could check your answer, maybe. I don't know. Another reason I would not necessarily give you a picture for this one. Like this is topic number 12 on the big list. Number 13 is to actually draw the regions on the picture.
Okay.
So that's kind of in my mind, that's a separate thing.
Okay.
For this problem, all that is required is think about the threshold and like multiples of the threshold. To me, this is not about the picture at all. Right? Okay, let's do one with the pictures though. So this is number 12 on the big list, determining possible outcomes. And there are 2 problems on the homework that are exactly like this, but with different numbers. Is that feeling better? Okay,
yeah.
I hope that seems okay. What I would like to talk about next, this will be on the big list, number 13 on the big list. Draw possible outcomes. Like I was just saying, to me this is a different kind of a thing. It is a different matter to actually draw them out. And for this, I want to go back to this this handout that we talked about last time, and I brought some more today just in case you didn't all save it from last time. So who wants another one? I hope you don't all want it, but I got it.
Yeah.
So this is something that I asked you all to do just kind of like in an unstructured way last time. But I want to really talk about how to do this in a more formalized way this time. So for this one, I'll get mine here. Come on. I want this. Okay. All right, so for this one, we have the setup here. You can count the little boxes if you don't believe me. Here we have 20 D's and 30 L's. And my instructions, so that's a total of 50. My instructions were, we want 5 districts of 10 each. And I would like to determine the possible outcomes, which is what we just did. So let's just do that one more time. We did this already last time. And then actually draw each one of them. So for the possible outcomes, I'm going to do this a little quicker this time just because we did exactly this example last time. Again, I'm going to start with, okay, these are just like, in theory, the D's could win all 5 and the L's could win 0. Or we could have 4 and 1. Or we could have 3 and 2. Or 2 and 3. Or 1 and 4. Or 0 and 5, right? So these are all the theoretically possible outcomes. Again, we are going to think about the threshold in order to determine which ones are actually possible. The threshold here, the threshold to win each district is, can anybody say? 6. Yeah. Is that what you said?
Yes.
6. Yes. I thought you said 26, which sounded crazy to me. She said 6. There are 10 each in each district, so in order to win out of 10, you need 6. If you get 5, that will be a tie, but to win, we need 6. All right, so the threshold to win is 6. And then look at the D's. The D's have 20 total, so how many could they possibly win? You want to think in terms of multiples of 6. Could they win 1? Yes, that's 6, and they have 20. 2 would be 12. 6 times 2 is 12, and they have 20, so they could do that. 3 would be 18. They could do that because 20 is more than 18, but 4 is too much because 4 times 6 is 24, which is more than 20. So the D's can win up to 3. That's what I just said. 3 would be, 3 times 6 is 18, and the D's have 20, so they can do that, but they couldn't win 4. All right, so because of that, the D's cannot win 4 or 5, so I'm going to cross off this one and that one, right? The D's can win up to 3, but not more than 3, so they can't win 4 or 5. And by the same reasoning, you think the same thing about the L's. How many could the L's win? The L's can win up to, can anybody say? In terms of the multiples of 6 is what you should be thinking about. I heard something, but I don't know what it was. 5. I think the answer is 5. They could win up to 5. 5 would be 5 times 6 is 30, and they have 30. So in theory, they could win up to 5. So that means actually, because of this, I'm not going to cross off anymore. Because actually, even this extreme outcome here is possible in theory. Because the L's, they really can win up to 5. And that's 5. All right? So the possibilities are right here. We have 4 actual possibilities. And I want to try to draw each one of them. All right. Now, last time I was asking you just kind of like informally to draw a bunch of different ones. So you probably already have drawn at least some of these. But I want to talk about like how could we sort of work this out in a more, how do you want to think this through in order to do this in a more serious way? So I'm going to look at the picture. And let's just try to draw from the most extreme one. The very last one here is 0 D's and 5 L's. All right, so to make 0 D's and 5 L's, I'm going to be drawing some little, border lines, some blobby things. And I want to make it so that L wins every time. So here, to make L win every time, again, what you should be thinking about in the back of your mind is the threshold, which is 6, all right? To make L win every time, we give 6 L's in every district. Give is a weird word. I will say put, maybe. It's up to me to decide where the districts go, right? 6 is the threshold. That's how many they need to win. So to make L win every time, we must put 6 L's in every district. Now, if I put 6 L's, each district, remember, has to have 10 total. So I will say plus 4 Ds, right? Just because I need to put 10 in every district that I draw. And if I'm going to put 6 Ls, that means I have to put 4 Ds, all right? So there's a lot of different possible sort of correct answers here. You can draw this however you like, as long as it works properly. I want to put 6 Ls plus 4 Ds. I think the simplest way to do that is just like that, right? This district has 6 Ls and 4 Ds. The Ls are the light squares, the Ds are the dark squares, all right? And the L's are going to win that one. And then I think it's pretty clear to see on this picture, you can just do that every time, right? In this case, the L's have 6 every time. The D's have 4 every time, so the L's win every time, all right? I am thinking in terms of the thresholds. Sometimes you might feel like, can I just sort of like do this by some kind of common sense? And the answer is, yeah, maybe you can. But if your common sense is failing you, you should always go back to the threshold of 6, all right? Okay, so that's how you make the L's win every time. Let's try, I want to do all of these different possible outcomes. Let's do the 4D and 0 Ds, okay, 1D and 4 L's. All right. I want to make the D's win once, but only once, and not any more than once. So the strategy here, there is a very common strategy that we always think about here. This is the language they use in real life when they're doing this. We're going to pack one district full of D's so that they win one, because our goal here is to make the D's win one and lose all the other ones, all right? This is called packing. I'm going to pack one district full of D's and then crack the rest of the D's so they can't win more than one. This is the basic strategy that goes into gerrymandering in real life. It's called packing and cracking. Packing means you make one district that's just all D's or mostly D's. So I'm going to put maybe like this is, I think, the simplest way to do that. All right. This is all D's over here. That's the packed one. This is what you will see this in real life when people do gerrymandering. This is packed, as they say. All right? Why should you pack them all into one? It's because now there aren't very many left over, and the other ones I can crack. That is to say, I'm going to divide up the other ones so that they can't win. So for instance, I'll take the next 4 D's and put them together with a bunch of L's. Like I said, there are many ways you can do this. But how about like that? This is a L victory, all right? I took 4 D's and 6 L's. Now I still have 6 D's remaining. I'm going to crack those into 2 separate districts also. And we have to be a little careful that we don't run out of squares. Actually, I don't really like how I drew that line. This is a common thing. Actually, you may find yourself going back and changing your mind a little bit, just because it's a little crowded down here. So I'm going to draw it, sorry about this, I'm going to draw it going up a little more. How about like this? Make sure you get 10 in each district, but I had 4 dark ones there and then 1, 2, 3, 4, 5, 6 light ones. How about like that? I like this better. I didn't want to cut off the area at the bottom too much. All right. Okay, I am cracking the remaining D's. Now we have 6 dark squares down there. If I put them all together, then the D's will actually win that district, but I don't want that to happen because I want the D's to win only one. And so I'm going to divide them up even more. So maybe I'll take the bottom 4 here and put them with those, where the lights will win this one. And then there's only 2 D's left, and they'll just go with a bunch of white ones when I divide this region up. It has to have 10 things in it, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. How about that one? Like that. All right? You got to count them up carefully to make sure you get the proper number. That's going to be 1 by the L's. There's only 2 dark ones in there. All right? And then there's a bunch of light ones left over. They'll just all go together. All right? So this is the strategy that you are usually going to think of. You have the threshold in mind, which is 6, and then here to make the D's win only once, but no more than that, you pack 1 full of D's, and then you crack the D's on the rest of them. All right? This is the classic gerrymandering strategy. Yes?
On the test, will we be asked to draw this out, or are we going to be asked like the question we just did where you have to write it out?
Those are 2 separate things on the big list. So number 12 is determine possible outcomes, which is not this, and then number 13 is draw the districts, which is this.
Okay. All right.
But this drawing thing will not appear on the test on Friday, just because we're only just doing it right now. All right. Okay, that was 1 D's and 4 L's. Can we do? I have two more possible outcomes, right? I'm trying to draw an example of each of these ones. So I just did the bottom 2. Let's do 2 D's and 3 L's. This one also, we are going to think in terms of packing and cracking. So here, I want 2 D's, 3 L's, right? This time, I'm going to make my 2 dark districts and then think about the 3 L's. So let's make 2 packed D districts. And you can see this is pretty easy to do on the picture here. Remember, in the previous example, I packed 1 D district like this, and then I cracked the other D's. But actually, this time, I actually want the D's to win twice. So I'll pack 1 like that, and you might as well pack the bottom one also to make the D's win that one also. So it's like this. All right. Make 2 packed D districts. And now I can just divide up, like I want the D's to win 2 and the L's to win 3. So now you can just divide the light ones however you like. Remember, it has to be 10 in each district. But I can take these, that's 9 there, plus 1 more like that. And then this is maybe like this and that, something like that. You just have to divide these up so that there's 10 in each region on the right side. All right, so I made 2 packed D districts, and then there's just no D's left, and so the L's can win all the other 3. All right, and then finally, my last possibility would be 3 D's and 2 L's. Let's do one like that. Sorry to scroll away from the one that I just did. 3 D's and 2 L's. All right. This one, I am again going to think in terms of packing and cracking. Although I think maybe it's better in this case. Well, I'm thinking about the threshold, right? Remember, we need 6 to win each district. That's the threshold. Each district. And I want D's to win 3, which requires 6 times 3, which is 18. So it is possible, but like only just barely possible for the D's to win 3 here, right? The D's have 20. They need a total of 18. There's only like a couple extra. So what I'm going to do is I'm going to make 3 districts where the D's have 6 or 7 in each, all right? And then you add in some of the L's to even it out. So for example, I will take the top 6 D's here and then just add in, just to make 10, I add in 4 light ones. So this one is a D majority. I'll take the next 6 and add in 4 light ones. The next 6 here, and add in 4 light ones. That's also a D majority. And can I get a D majority a third time? Yeah, we have 8 more D's down here, and I can put them together with, say, 2 more light ones. and that's a D majority. All right, so there's my 3 D districts. And then how do I make the 2 L's? Well, everything that I haven't done yet is all L, so you can just divide those up however you like. And this will be, maybe I'll take these 4, remember they have to be 10 in each, so these 4 plus those 6 would be 10 right there. That's a L, and then this weird shape here is the other L. All right. There is a lot of, personal freedom or something, like many different possible correct answers to a question like this. All right. Any thoughts about that one? You should at all times be thinking about the threshold of 6. That's the important thing here. As I was drawing these, I was saying I want the D's to win 3, so I take these 6, and then these 6. Actually, they were 2 extras, so there's 8 here. All right. All right, I got another completely different example. This one is a little unrealistic. I mean, just because the D's and the L's are all like in these like blocks, these stripes. That is not typically going to be the case. So let's try another. Here's another one. This one has the squares kind of all mixed together. And this is a more typical example that you would see on our tests and homework. All right. So you see this one here, and I'm going to I suppose it doesn't really matter, but you might want to turn your paper the right way up. Come on now. There it is. Okay, I'm going to hold my paper so that it's this way around. What you see here, you could count these up for yourself, but I will just tell you. What you see here is 64 total squares. This is an 8x8 grid here, so there are 64 total squares. And actually, there's an even split. There's 32 light and 32 dark. All right, and your job, I would like you to make 4 districts of 16 voters each. All right, and I would like to, first of all, determine what are the possible outcomes. That you can do without really looking at the picture. And then also actually draw those various possible outcomes. All right. So let's talk about the possibilities first of all. We have, without really thinking it through at all, there are 4 total districts. So it could go 4 and 0, or 3 and 1, or 2 and 2, or 1 and 4, or 0 and, 1 and 3. Oh no. Or 0 and 4, right? Not all of these are actually possible, though. We should think, as always, in terms of the threshold to win each district. Can anybody say what's the threshold in this case? 9. It is 9. Yeah, each district has 16 voters each. So to get a tie, you would need 8 out of 16, but to win, you would need 9 out of 16. So the threshold per district is 9. And then we want to think, okay, that means the D's can win up to, you should think about the various multiples of 9, and then they have, I set up here, there are 32 D's here, or you could count them up if you don't believe me, but there are. The D's can win up to, what do you say? 2, 3, 4?
2.
You should be thinking of multiples of 9, and what's the biggest multiple of 9 that you can get with 32? I think the answer is 3. 9 times 3 is 27. 32 is more than 27, but you cannot get 4. 9 times 4 is 36, which is more than 32. So the D's can win up to 3. That's because 3 times 9 is 27, and 27 is actually less than 32, but 4 times 9 is 36, which is more than 32. All right, so the D's can win up to 3, and the L's, actually, they're the same number of D's and L's, so whatever I say about the D's is going to be the same for the L's. The L's also can win up to 3, all right? So in terms of the possible outcomes, that is not possible, and that's not possible. You can't get 4 D's, and you also can't get 4 L's, but the other ones are possible, all right? All right, and let's try to draw each of them. So let's draw each of them. So that much of it actually could appear on our test on Friday. This is just determining the possible outcomes, which is the same thing we've done a few times. Now, drawing them, this is something I'm not going to put on the test for now, but I would like 3 of these. Sorry, it takes forever to add a picture. I don't know why. All right, give me that. Okay, come on now. All right, so the 3 possible outcomes, they were 3D, 1L, 2 and 2, and 1D, 3L, right? Those were the 3 different possible outcomes. Let's see if we can draw each one. Maybe I'll let you all try this. We got a few minutes here. So my advice for the first one there, here I would like to pack 1L and then let the D's win the others. Remember, what I mean by that is make one district that's like almost all L's, and then there just won't be enough L's left over to win any of the others. That's my strategy for 3D, 1L. And then a similar strategy over here, 1D, 3L, I would say pack 1D. And then let the L's win the others. And then the one in the middle is more of a sort of equitable division for the middle. I'll let you think about how to do that. Keep in mind the threshold of 9. Feel free to chat with your friends about it if you like. Make sure to put 16 in every district that you draw. I gave you lots of different copies of the picture in case you mess it up. the idea is you want to like load up all the L's here so that there just aren't very many.
Yeah. Oh, yeah.
And that's ideally, you would put all L's. I know sometimes it's just not possible. Try to draw. How you guys doing? Yeah, this is good. You're not taking my suggestions. I would, so my advice for this one is to pack one L. That means I want to make one district, which is pretty much all L's.
What about this one? Does this look good?
2 and 2? I think so.
Okay.
Yeah, that one is just. Sorry, it's about time to go, so I'm gonna real quick here. The first one here, the leftmost, 1L, I said pack 1L. A lot of people just like decided not to take my advice, which is okay, I guess. But what I mean by that is I'm gonna make one district, which is pretty much all L's. Now, I don't know if that's really geometrically possible here, but check this out. This is how I'm thinking this through. I'm taking as many L's as possible in the first one here. So this is 1, 2, you got to count them up, unfortunately. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that many. I'm taking the L, as the kids say. I think that's 16 L's. So the L's definitely will win that one. Why did I do that? It's because now there's hardly any L's left over in the rest of the picture, and so it will be fairly easy to make the D's win all of the others. So over here I have, this is 9 D's plus, I need to get to 16 here. So again, I have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How about that? And that one, the D's will win. They have 10 dark and only 6 light. And then over here, there aren't really enough L's to win anymore, so I can split these up pretty much how I like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll take those, that many. I'm sure none of you drew yours exactly the way that I drew mine, but I hope that you did them somehow like that. Because I made all L's in the first one, it makes it so that there aren't enough L's to be a threat in any of the other ones, and it became easy to divide up the rest of them. All right, I think maybe it's time to go. This 2D, 2L, you can pretty much make up whatever you like, and I think actually in this example, if you just do that, it makes an even 2 and 2. I believe that that works. Maybe we'll just fill this one in at the beginning next time, which will be next week. All right. Have a good one.